Question 22 says, a Young's double slit experiment is performed using monochromatic light of wavelength lambda. The intensity of light at a point on the screen where the path difference is lambda is k units. The intensity of light at a point where the path difference is lambda by 6 is given by nk by 12, where n is an integer. What's the value of n? Now the question is clearly from the wave optics and it's based on Young's double slit experiment. The expression for intensity is given as intensity I is equal to the maximum intensity I naught into cos square phi divided by 2, where phi is the phase difference between the waves reaching from the two sources at a given point on the screen, right? So this is the expression, and the question further says that, where the path difference is lambda, the intensity is k units. So where the path difference is lambda, we know that there is going to be constructive interference, the intensity is going to be maximum. That means according to the question, I naught is k. So we have intensity I given as k, which is the maximum intensity, cos square phi divided by 2. Now let's consider the other point where the path difference is lambda by 6. If the path difference is lambda by 6, the phase difference phi there can be given as 2 pi by lambda into lambda divided by 6, and this is coming out as pi divided by 3. So that is the phase difference at the other point. Okay, so now we can put phi as pi by 3 in this particular equation and get the intensity at the other location. Let's call this intensity as I dash. So we have I dash is equal to k cos square phi by 2. That means it is equal to k into cos square of pi by 6. And what's the value of cos square pi by 6? That is 3 by 4. That means this is cos square pi by 6, whose value comes out as 3 by 4. So this is coming out as 3k divided by 4. Now, and if we equate this with nk by 12, the value of n comes out as 9. So that means answer is 9 for this particular question. Let's fill in 9 here, and we can now go to question number 23. Question 23 is based on thermodynamics. Let's look at the statement of the question. It says, an engine operates by taking a monatomic ideal gas through the cycle shown in the figure. The percentage efficiency of the engine is close to. So we have to find the efficiency of the cycle which had been shown. We notice that the process AB is isochoric process in which the pressure is increasing. So that means while the work done is 0, the system is absorbing some amount of heat. Let's call that heat as Q1. So Q1 amount of heat is being absorbed here in the process AB. Similarly, if you look at the process BC, that is an isobaric expansion and some amount of heat is being absorbed here too. So the system is taking Q1 and Q2 amounts of heat in these processes AB and BC. In process CD, the system will be releasing some amount of heat because it's an isochoric process in which the pressure is decreasing. So some amount of heat is going out, and further in the process DA, some amount of heat is again going out. So the expression for efficiency would be the total work done in the cycle divided by the heat absorbed in the two processes. That means work done divided by Q1 plus Q2. What's the work done? So let's first of all put the formula that efficiency is work done divided by Q1 plus Q2. Now, what is the value of W, the work done? Well, that is area of this rectangle, and the area would be V naught multiplied by 2 P naught. That means work done is 2 P naught V naught. Let's write it here. So we have work done as 2 P naught V naught. Now we need to evaluate Q1 and Q2. Now remember, the gas is a monatomic gas. The process AB is isochoric process. The heat absorbed Q1 is nothing but the change in the internal energy of the gas in this process. So that means we can say Q1 is equal to the number of moles N multiplied by CV of the gas, and CV, because it's a monatomic gas, CV is 3R by 2. So that means N into 3R by 2 TB minus TA. So TB minus TA, that is the expression for Q1. In terms of P naught V naught, if we want to express this, then we see that P naught into V naught is in fact equal to nRTA, and 3 P naught V naught is nRTB. So if we make that substitution, the expression for Q1 then becomes, it is equal to 3 by 2 into 2 P naught V naught. That is the value of Q1. This is coming out as 3 P naught V naught. Let's also evaluate the value of Q2. Now Q2, because the process is isobaric expansion, will be given as N multiplied by C for the process, and C for this process is Cp, which is 5R by 2. So N into 5R divided by 2, and the temperature goes from Tb to Tc. That means we have to put a factor of Tc minus Tb. So this then comes out as 5 by 2 into nRTC, and nRTC we can see it is 6 P naught V naught, and nRTB we have seen it is 3 P naught V naught. So the difference would be 3 P naught V naught. So let's put it here now. So this is coming out as 5 by 2 into 3 P naught V naught. So now we have all the three terms required for finding the efficiency, W, Q1 and Q2, and all are in terms of P naught V naught. So if we put that, the efficiency can be easily found out, and the value of efficiency comes close to 19%. So let's fill in 19 here. That's what we were supposed to find. Or efficiency of the engine is coming out close to 19%. It's time now to go to question number 24.